Okay, listen. So first I will explain the basic concepts, okay, in this chapter. What is the name of this chapter, ma? Chapter number 6.
Triangles.
Triangles. Very good. Triangles. So chapter 6, okay, the name is triangles. Now listen. So there are two words we have to understand, and we should know the difference between these two words. The first one is most of them will use the word called congruent. Okay, one word is congruent, and another word is similar. Congruent and similar. So first thing, I will give a simple example. Okay, from a real life example. So for the meaning of congruent, for example, if I'm telling these two objects or these two shapes are congruent, these two, what to say, images are congruent. Congruent means exactly same shape as well as same size. Listen carefully, ma. Again, I'm saying again, same shape and same size. This is congruent. Okay, this is the meaning of congruent, right? You know this, right? Yes, sir. Yes or no?
Yes, sir.
Okay. Now, for this example,
Yes,
okay, for congruent, okay, I can give us some example. In real life example is, for example, okay, suppose you can take any two class, I would say, notebook in your school. They are giving, for example, 5 notebooks, means all the notebooks are same shape as well as same size, right? Sorry, ma, this is same shape and same size, same size. Okay, this is the example for congruent. Okay, this is the example for congruent. And now similar means the shape is same. Okay, the shape is same, but size is different. But different size. But different size. Okay, for this an example is, suppose if your school is they are having a uniform shoe. Actually, for uniform you will wear shoes means for some person, okay, they will wear size. Okay, they will have a shoe size 8, number 8, and some students will have size number 7. But the shape of the shoe, okay, the design, everything is same for all the students. Only the size differs. Only the size differs. So that is an example for similar. Similar means it looks same, but actually it is not same. But congruent means exactly same. Same in shape as well as same in size. That is the meaning of congruent. For example, I can tell you now, listen carefully. This is, I'm drawing 2 squares. This is one square and this is another square. See here, the shape of the squares, 2 squares I have drawn here are same. Both are the same shape. The shape is same, but the size, see the size, is it same or different?
Different.
Different. Yes, it is different. So see here, these two, okay, squares are called as, they are similar to each other. They are similar to each other because having same shape but different size. Then we have to say they are similar. Okay, they are similar. But in this question number B, see here. Suppose if I am drawing 2 squares with the same shape, same size. For example, you can see the tiles. Mostly we'll use tiles, right, in the home. Okay, in the floor we will use tile. You can see all the tiles will be having same, will be in the shape of square. Okay, square means all the squares are similar to each other. All the squares are similar to each other, but the size may differ. But usually in the floor we'll use the same size also. For example, here also I have drawn 2 squares, and for the 2 squares, if the size is same, means then we have to say they are congruent. These 2 squares are congruent to each other. They are congruent to each other. Now, in question number 3, see here, in question number 3, state whether the following quadrilaterals are similar or not. Similar means, listen, ma, this is the shape. Listen, here one shape is given like this, and the dimensions are given. What is the dimensions of this shape, ma? 1.5. All the sides are 1.5. Yes or no? Okay, PQRS. Listen, the 4 vertex, or we can say vertices of this shape is PQRS, and all the sides are 1.5, 1.5, 1.5. But please answer me, even though all the sides are 1.5 equal, but is this a square? This shape PQRS is a square or not?
No, sir.
No. Very good.
Sir.
It is not a square. It is not a square. Listen, why it is not a square?
Because it is not
The angles are not equal.
Listen, very good. Listen, ma, if the interior angle is not 90 degree, actually see here, the interior angle is not 90 degree. The interior angle is not 90 degree. In square, all the interior angles are 90 degree. But if all the sides are equal, but the interior angles are not equal as well as not equal to 90 degree means, then what is the name of this shape?
Rhombus.
Rhombus. So it is rhombus. Okay, RHOMBUS. Okay, it is rhombus. This shape is called as rhombus. And near to this shape, they have given one more shape. What is the shape, ma? Here, all the sides are equal, 3 centimeter, 3 centimeter, 3 centimeter. Okay, all the sides are 3 centimeter, and as well as, and all the interior angles are equal to. They have mentioned like this. This represents it is 90 degree, right?
90 degree.
90 degree. So all the interior angles are 90 degree. Therefore, what is the shape? It is a
Square.
Now listen carefully. For any square, when we compare two squares, means they will be surely similar, because the shape of all the squares, whether it can be a small square or big square, all the squares are having the same shape, but okay, it vary by the size. But here they are comparing a square with shape, rhombus. Now when we compare a square with rhombus, is it having the same shape or different shape?
Different
shape.
Different shape. Very good. So therefore, what you have to do is, here they are asking, state whether the following quadrilaterals are similar or not. Now tell me whether it is similar or not.
It's not similar.
Yes, it is not similar. Therefore, the answer is, you have to write, it is not similar. Okay. Therefore, one shape is rhombus and another one is square. Therefore, the two given shapes are not similar. Similar means it should have the same shape. Given two, don't write two shapes, given the two given quadrilateral. So quadrilateral means it is a four-sided shape. Any four-sided shape, the common name is quadrilateral. Therefore, the two given quadrilateral are not similar. They're not similar. Okay, please write. Okay, any finished, Amma? Okay, now next, which question you want me to teach? I can't erase this red color line. Okay, those of tried, okay, drawing lines, please erase this one. Okay.
Sir.
Yes, thank you so much. Yeah, next, which question, da?
Exercise 1.1.
Exercise 1.1. Yeah, 1 minute. One student asked exercise 1.1. Question number
1.3, sir.
1.3, question number 1. Okay, all of you write that question, ma. Exercise 1.3. Exercise 1.3, question number 1. Okay, I'll take the question, ma. Please wait.
Sir, we can say that triangle is not that.
Arida?
Sir, we can say that question number 3 is not equal. Like that also we can say no, because their corresponding angles are not equal and their ratio of their corresponding sides are not equal.
Oh, you want to write the reason, huh? You want to write the reason?
Yes, sir. 1
minute, ma. 1 minute. Wait. I'll tell you whether we have to write. We need to write in that further question. 1 minute. I'll read the question again. If for some question it's not needed to mention the reason, but here I will check. 1 minute. Give me a minute. Exercise 6.1. Or simply you can write, ma, for this previous question. Okay, since the corresponding angles are not equal, they are not similar. Just write the answer like this, ma. Or else you can write like this: the two given quadrilaterals are not similar because you can add this also, because the corresponding angles are not equal. If the corresponding angles are equal only, then we can say they are similar. Here the corresponding angles are not equal. For one shape, for one quadrilateral and interior angle is 90 degree, but for the another quadrilateral interior angle is not equal to 90 degree. Therefore, the two given quadrilaterals are not similar because the corresponding angles are not equal. Because the corresponding angles are not equal.
Basmar.
Okay, please copy this. And mute mark. This is the answer for the previous one. Okay, ma?
Yes, sir. Okay, sir.
Okay, ma. Now prove that root 5 is irrational. Actually, I have already taught you this sum in prove that root 3 is irrational. Yes or no?
Yes,
Yes.
sir.
Okay, do you want me to teach it again? This prove that root 5 is irrational?
Yes, sir.
Okay, I'll teach. Okay. So while teaching, please listen, ma. While I'm teaching this sum, I'm ready to teach it again. This is very, very important question, but you have to ask me doubts. Whenever in any particular step, okay, if you are feeling difficult means, please ask me, then I will explain that same step in a different way so that we'll be able to understand. If you are not able to understand, please ask, okay? In this step, you are not able to understand that step itself, you have to stop me and you have to ask your doubt. Okay, then then only you can clarify your doubt. Okay. Now I'll start the question. Here the question is it is very important question. Prove that root 5 is
Sir,
yes, ma.
did isosceles triangle is similar? They can be similar isosceles triangle.
You are asking isosceles whether any two isosceles triangles are similar or not. You are asking, yes or no?
Sir, yes, sir.
No, ma. Listen, all the isosceles triangles are not similar because the reason is, see, I will explain that. 1 minute, ma. Okay, everyone see here. Wait a minute. I will explain why it is not similar. See here. What is the definition of isosceles triangle?
Their two sides is equal.
The
Any
two sides are
are equal.
1 minute, ma. Wait a minute. Okay, listen. 1 minute. So you are asking whether they are similar. You are asking, right?
Yes, sir.
Okay, wait a minute. Wait. Okay, listen. So this is an isosceles triangle in which I'm considering this angle as 30. If this is also 30. Isosceles triangle means two angles are equal in a triangle. If two angles in a triangle are equal, then we call it as isosceles triangle. As well as the sides opposite to equal angles will be equal. For example, for this 30 degree, this is opposite side. And for this 30 degree, this is opposite side. So therefore, AB is the side which is opposite to this 30 degree and AC is the side which is opposite to this 30 degree. And these two sides are equal. AB is equal to AC. And here I'm drawing another isosceles triangle. Let it be PQR. And here the base angles are 40 degree and 40 degree. Just assume base angles are 40 degree and 40 degree. Now see here now. If these two are 30 and 30, 30 plus 30 is 60. And what is this angle? 120. Okay. This is 120. And what about this one? This angle is 100. Yes or no?
100.
100 because 40 plus 40 is 80. So 80 plus 100 is only 180. Because for any triangle, sum of all the three angles, interior angles will be equal to 180. Now see here, ma. These two triangles are okay. These two triangles are having a one second. The definition for similar is it should have the same shape. Yes or no?
Yes, sir.
But
Same
shape, but different size. Size can be different. The meaning of same shape is, listen, when you, for example, ma, you can see usually we can zoom any pictures, right? Usually we'll do that. Zoom in, zoom out. Okay, zoom in, zoom out. That time what will happen is, when you zoom, okay, when you zoom up, okay, image, the ratios of all the sides will increase in a standard way, okay, in a equal way. For example, the shape will not change if you zoom in or zoom out, but the size alone differs. But here the shape itself is differing, right? The shape itself is
Yes, sir.
differing, right? 1 minute. 1 minute. Please give me a minute. I'll think about it. 1 second. 1 second. Okay, listen. That is one more thing. But as for the definition, listen, ma. Okay, according to the definition, if two shapes are similar means their corresponding angle should be equal. But here the angle is 40, but here the angle is 30 degree, right? So that itself says these two isosceles triangles are not similar. But why we are saying two squares are same means because for a square which is small in size also the interior angles are 90, 90, 90, and for the bigger square is also all the interior angles are 90. Therefore, corresponding angles of any two squares is same. But what about equilateral triangle? What about two equilateral triangle?
They are similar.
They are similar. Very good. Because even though this triangle is small, 333 centimeter, all the sides are 333. Here, all the sides are 666. But interior angles of any equilateral triangle is equilateral. So equal sides. That is the meaning of equilateral. So if all the sides of a triangle are equal means, then all the interior angles will be equal. That is 60, 60, 60. For this triangle also the interior angles are 60, 60, 60. Hence, for equilateral triangles, on comparing any two equilateral triangles, okay, they will be similar. But for isosceles triangle, it is not similar. Okay, ma? Are you able to understand the difference, ma? Why it is not different?
Yes, sir.
It's not similar. Okay, now we'll move on to the question number 1 in exercise 1.3. Now listen. This is question number 1 in exercise 1.3. Prove that root 5 is irrational. Prove that root 5 is irrational. Now listen, ma. This sum alone we are going to prove it in a different way. So for that, the steps, okay, you have to write the same step in exam also. First step is you have to assume that instead of, okay, we have our aim is to prove this root 5 is irrational, but we are going to assume that root 5 is rational. Then we are going to proceed. So all of you write the first step, ma. Please write side by side. Okay, first step. Let us assume, okay, this is the step you have to use in your exam also. Let us assume that, to the contrary. To the contrary means to the opposite, because we have to prove it is irrational, but to the opposite we are assuming it as rational. Let us assume to the contrary that root 5 is rational. That root 5 is rational. We all know what is a rational number. Yes or no? We all know what is a rational number. So rational number means a number which is in the form of P by Q. Do you remember that the definition of rational number? A number which is in the form of P by Q. So that is called as rational number. So here also we are assuming this root 5 as rational. Since we are assuming this as rational number, so what I'm going to do is, so therefore I'm going to express this root 5 as, okay, I'm going to express this root 5 as A by B or P by Q. Small p by small q or A by B. Please mute the audio. Kindly mute the audio. So I'm considering this root 5 is equal to A by B. And one more thing is where this A and B are. Listen, we have to mention it clearly here. Where A and B, okay, A and B are co-prime integers. Or what kind of integers, ma? Both is A and B, co-prime integers. What is the meaning of co-prime? Co-prime integers and comma, this denominator is not equal to 0. B is a non-zero, okay, B is non-zero integer. Now listen, the meaning of this co-prime integer is very, very important. Okay, I can give an example for that. For example, 2 and 5 or 2 and 4, sorry, not 2 and 4, 2 and 11 or 3 and 5 or 3 and 4. Listen, ma, any two consecutive numbers are co-prime. This is an important one mark. Any two consecutive numbers are co-prime, because co-prime means if the two numbers are not having any common factor except one, then we can call it as they are co-prime. Are you able to understand, ma? What is called as a co-prime number? Listen, for example, 3 I'm taking. This is rough for rough. Okay, rough work I'm using. Wait a minute, I'll use another color. So whatever I'm writing in the black, you have to write it for this sum. This is for your understanding. For 3, what is the next number after 3? 4, right? These 2 numbers are always coprime. Any 2 successive numbers are always coprime, which means for 3, the factors of 3 are 1 and 3, because 3 is exactly divisible by 1 and 3. But for 4, the factors of 4 are 1, 2, 4. 4 is exactly divisible by all the 4 numbers, 3 numbers. Now see here, for 3 and 4, the common factor is only 1. That is why we can say 3 and 4 are coprime integers, coprime numbers. Are you able to know the difference? Know the meaning of coprime, ma? Yes or no?
Yes, sir.
Yes. Now listen, I'll write the next step. Now what we are considering is, first we have assumed that, we are assuming to the opposite, that is, we are assuming to the contrary that root 5 is rational. Our aim is to prove root 5 is irrational, but we are assuming it as root 5 is rational. Since we are assuming root 5 as rational, a rational number can be expressed in the form of p by q, or we can use another alphabets, that is a by b. Can be expressed in the form of a by b. But here I'm taking this a and b are coprime integers. A and b are coprime integers. Now listen, next step. After that step, now what we have to do is, we got root 5 is equal to a by b, right? Again, I'll write the same step, no need to write it again. If I have already written, root 5 is equal to a by b. Now I'm going to take this b, which is in the denominator, that means which is in division, to the left hand side. I'm going to take this b to the left hand side, and the number or alphabet which is in the denominator, when it is taken to the opposite side, becomes multiplication. It becomes multiplication. So root 5 into b, root 5 into b, which is equal to, what will be there in the here? It will be a, because division becomes multiplication when it is taken to the opposite side. The number in division or alphabet, this variable will taken to the left hand side, becomes multiplication. Now root 5 into b is equal to a. Now next step is, we have to do squaring on both sides. This is very important step. Next step is, we have to do, because we have to remove the square root. To remove the square root, what we have to do? We have to do squaring on both sides. Squaring on both sides. Now when we do squaring on both sides, what will happen is, first step what you have to do is, you have to put root, because in the left hand side we have root 5 into b. So root 5 into b the whole square, which is equal to, right side is a, so it becomes, you have to put a square. Root 5 into b the whole square is equal to a square, right? Now we have to bring down this square inside separately for root 5 and b, because it is of the form a into b the whole power m, or we can write, that can be expressed as a power m into b power m, right? A into b the whole power m is a power m into b power m. Now I'm going to put this power 2 inside, that is for root 5 as well as b separately. Now next step is root 5 the whole square, root 5 the whole square into b square. This root 5 the whole square into b square. This is equal to a square. This is equal to a square. Now root 5 the whole square means, we have to first, this square and square root gets always cancelled, so we'll get 5 into b square. 5 into b square is equal to a square. Please write up to this one. 5 into b square is equal to a square. Please write up to this step. Completed, Amma?
Yes, sir.
Yes, sir.
Yes,
sir.
Okay, listen. Okay. Now listen carefully. This is very important step. Now since 5 into b square is equal to a square, the meaning is, therefore, I can write this. After this I can write like this. 5 divides, therefore 5 divides a square. This is very important step, because since this a square is, a square is expressed as 5 times b square, because 5 times b square is a square, which means this a square is divisible by 5, or we can write 5 divides a square. Are you able to understand this? I'll give an example for that. Using another color. This is for your understanding. For example, 3 into 6 is equal to 18. Listen, ma. 3 into 6 is equal to 18 means the product of 3 and 6 gives you 18. Then we can tell this 18 is divisible by 3 as well as this 18 is divisible by 6. Yes or no? 18 is divisible by 3 or not? Yes. Likewise, 18 is also divisible by 6. Or 18 is divisible by 3. The same thing can be expressed like 3 divides 18. Yes or no? In other words, we can say 18 is divisible by 3, or we can say 3 divides 18. Both are same. having the same meaning. Yes or no? Similarly,
Yes, sir.
here 5, the product of 5 and b square will give you a square. The product of 5 and b square giving a square, which means this a square is divisible by 5 as well as this a square is divisible by b square. So that is why I'm writing this, okay, in this step, like that since a square is divisible by 5, the meaning is 5 divides a square. Is it now, are you able to understand this step? Why 5 divides a square?
Yes, sir.
Yes or no?
Yes.
Okay, please ask your doubt, Ma. If you are not able to understand this step, please ask. Again, I'll explain in a different way so that you will understand. Okay. Now, next step. See here. Since 5 divides a square, listen, Ma. Since 5 divides a square, 5 also divides a. Okay, therefore, I'll write it. Therefore, 5 divides a. This is because of a property. That is the theorem. 5 divides a. 5 divides a. I'll tell you what theorem it is. Okay. It is given in your book. I don't know which page number it is there, but in my textbook, it is page number 12. Anybody have doubt, Ma? Please ask it out. Okay. Listen, I will teach you now. What is the meaning of the theorem is? All of you write the theorem, Ma. That says, listen, Ma. I will okay. Please write, Ma. Okay, write this theorem so that you will remember this forever.
Excuse me, sir.
Yes, Ma. What is the doubt?
Could you explain again, sir?
This 5, how it is 5 divides a?
Sir, from A, where A and B are co-prime, sir, from there.
From this step, Mama, 5 into b square is equal to a square. From this step.
From, no, sir, from root 5 equals to A by B.
From root 5 is equal to root a. Root 5 is equal to a by b. This step.
Yes, sir.
Okay. Listen, Ma. Why we are writing root 5 is equal to a by b? Are you able to understand first?
Yes.
Because we are
Sure.
assuming this root 5 as rational. A rational number will be in the form of numerator by denominator. Yes or no?
Yes, sir.
That is why I am writing this root 5 as a by b, but I am considering this a and b are co-prime integers. Co-prime integers means for a and b there is no common factor except 1. That is the meaning of co-prime integers. That you understood, right?
Yes, sir.
Okay. Now listen carefully. I'll use this color. First step, what I'm doing is I'm moving this b, which is in the denominator, to the left hand side. When a term or number which is in the left hand side, when it is taken to the opposite side, becomes multiplication. You know that rule, basic rule.
Yes, sir.
So that is why we got root 5 into b is equal to a. This b, when taken to the opposite side, becomes multiplication with the number which is in the left hand side. So root 5 into b is equal to a. Are you able to understand this step?
Yes, sir.
After this step, what we are doing is, for our convenience, because we have to prove finally root 5 is not rational. For that only we are doing this kind of steps. Okay. Now, in order to remove this root, I'm going to take square root, squaring on both sides. I'm doing what step? I'm doing squaring on both sides.
Both
This for this equation, root 5 into b is equal to a. Now, root 5 into b the whole square is equal to a square. Root 5 into b the whole square is equal to a square. Are you able to understand now?
Yes, sir.
Now, after taking square root, listen, Ma. After doing squaring step, listen. This squaring. This power 2 is common for root 5 and b because it is whole to the power of 2. Root 5 into b the whole square. Now we have to bring down this square separately for root 5 as well as b, because this is the formula a into b the whole power m. Okay, is equal to a power m into b power m. Okay, this is a rule, actually law in exponents. A into b the whole power m is a power m into b power m. Using this law, root 5 into b the whole square is root 5 square into b square. Are you able to understand this step? Next step, which is equal to a square. I'm writing as this.
Yes, sir.
Okay, now see here, root 5 the whole square means root and square root. Square, this is square root and this is square. Square and square root already gets cancelled. So what will get? 5.
5
into b square is equal to a square. Now I will able to understand this step.
Yes, sir.
Okay, now next step is, listen. This is what I told you. Since here we got 5 times b square is equal to a square. 5 times b square is a square. Simple ma. You all know what is 3 table, right? 3 into 5 is 15, right? 3 5s are 15. Now 3 5s are 15 means this 15 is divisible by 3. As well as this 15 is divisible by 5. Or we can write 3 divides 15. Yes or no? 3 divides 15. So similarly, since 3 into 5 is 15, 3 divides 15. Similarly, 5 into b square is a square. Therefore, this 5 divides a square. Yes or no? Are you able
Yes,
to
sir.
understand this step? 5 divides a square. Since
Yes,
5
sir.
divides a
Sir.
square, listen. Since 5 divides a square, 5 also divides a. This is the very important step, because this, why we are concluding like this is because of a theorem that says, okay, I'll write the theorem now. Please, all of you write the theorem. Whatever I'm writing here, please write the theorem. Okay, it is mentioned as theorem 1.3, but I'll just, okay, write the definition of the theorem. That says, if listen, write like this. Let P be a prime number. Let P be a prime number. All right. Let P be a prime number. Full stop. Okay, P is any prime number. For example, what is the first prime number? What is the only even prime number?
2.
1.
1.
2, right?
2.
The only prime number is, the only even prime number is 2. And after 2, what is the next prime number?
4.
4.
No.
3.
3.
3.
Next after 3.
5. 5.
5. After 5.
7.
7. Very good.
7.
Listen, 2, 3, 5, 7. Okay. The few prime numbers. Okay. First, a few prime numbers are write it here. 2, 3, 5, 7. And after 7. Okay. 11. After 11, 13. And after 13, 17. Then 19. Then 23. Then 29. Okay. These are all the prime numbers. Listen, it keeps on going. So prime numbers means those numbers will have only 2 factors, 1 and the number itself. These numbers are divisible by 1 as well as the number itself. No other numbers will, okay, will divide this number. So listen, so let P be a prime number. Let P be a prime number. So now if P divides, listen, this is very important. If P divides A square, if P divides A square, then P divides A. This is the theorem. Then P divides A. Then P divides A. Full stop. Where A is a positive integer. Okay, you can put a comma where A is a positive integer. Where A is a positive integer. Okay, now I will explain this theorem. Okay, this is the theorem. Please write this theorem in your note.
Done, sir.
Done. Listen, the meaning is, for example, suppose, okay, I'll take one example here. I'll write it here. 2 is a prime number. Listen, 2 is a prime number. We all know that. Can anyone tell me whether this 2 is divisible by, is 2 divides 16? Yes or no?
Yes, sir.
Yes, sir.
Okay, 2 divides 6. Okay, this 2 divides 16. Now, this 16 can be expressed as 4 square. Yes or no?
Yes, sir.
So 2 divides 4 square. You all know this. Because 4 square is 16, 16 is divisible by 2, which means 2 divides 4 square. Since 2 divides 4 square, 2 is a prime number. Therefore, this 2 also divides 4. Because it is dividing 4 square means then it will divide. Okay, it will divide which number?
4.
Yes, 2 divides 4. Because of the property. See here, 4 is also divisible by 2. Therefore, this is just an example. Therefore, using the same theorem, we are applying here. In this, we have got a step like this. 5 divides A square. 5 divides A square. We know what is A. A is a integer. Now tell me, what about 5? 5 is an prime number or not? This 5.
Yes, sir. Prime number.
If a prime number divides A square means, according to the theorem, that prime number will also divide A also. Yes or no?
Yes, sir.
That is why I'm writing this step. Okay, therefore 5 divides A. Please complete up to this step. Therefore 5 divides A. Yes.
Completed, sir.
Finish. Now next step is, listen, we got 5 divides A. Now what we have to do is, since 5 divides A, this is also one more step, ma. So I can write it as therefore, since 5 divides A, therefore A is equal to 5 times some integer, that is C. I'm taking it as C. Therefore A is equal to 5 into C, where C is some integer. Where C is some integer. Okay, where C, okay, is some integer. Because, listen, ma, again I'll explain how it is. Since 5 divides A, therefore A can be expressed as 5 times C. Because this is here, this is the same example I will take. Okay, 3 into 5 is 15. 3 into 5 is 15. Therefore, we can say 3 divides 15. If 3 divides 15, this 15 can be expressed as, listen, ma, this 15 can be expressed as 3 into some number. Yes or no? 3 into some number, that is 5. Here 5. 3 into some number will give you this 15, right?
Yes, sir.
Similarly, here 5 divides A, which means A can be expressed as 5 times some number. That is the meaning. Therefore, A is equal to 5 into C, where C is some integer. Are you able to understand this step? Therefore, A is equal to, finished, Amma? Shall we move on to the next step?
Yes, sir.
Okay, now we got A is equal to 5 into C. What we got? A is equal to 5 into C. Now what I'm going to do is, I'm going to substitute this A is equal to 5 into C. Okay, I'm going to substitute this A is equal to 5 into C in this equation. So before that, what we can do is, okay, or else I will write like this, because we have already one equation that is says 5 into B square is equal to A square. In this equation, I'm going to substitute the value of A. Now what I'm going to do is, all of you write like this. Okay, I'll scroll down and write. There is no space here. So substituting, I'll write like this. Substituting A is equal to 5 into C in B square is equal to what we have, ma? Actually, what we have is 5 into B square is equal to A square, right? That the equation. Is that correct? Please check.
Yes, sir.
5 into B square is equal to A square. Yeah, in that equation we are substituting. We are going to substitute A is equal to 5C. So we are substituting A is equal to 5C in this equation. In 5 into B square is equal to A square. Therefore, which implies 5 into B square is equal to, in the place of A, I'm going to substitute 5C. So what will get? 5C the whole square. In the place of A, I'm substituting this 5C. So 5C the whole square. Now next step is 5 into B square is equal to, now we have to bring down this 5 inside for, bring down this square inside for 5 as well as C separately. So it becomes 5 square into C square, because 5C means 5 into C the whole square. This is 5 into C the whole square. So bringing down this square inside, so it becomes 5 square into C square. 5 square into C square. Now next step, which implies 5 into B square is equal to, now what is 5 square? That is 25. 5 square is 25. And into C square. 5 square is 25 into C square. Now I'm going to take this 5 to the right hand side. I'm going to take this 5 to the right hand side. What will be this 5, which is in multiplication taken to the opposite side, becomes division. So B square is equal to 25 into C square divided by 5. Divided by 5. Now 5 ones are 5, 5 5s are 25. So 5C square by 1 is simply 5C square. So B square is equal to 5 into C square. B square is equal to 5 into C square. Complete up to this.
Sir.
Yes, ma'am.
Sir, this 5 into C, sir. Can we take any other number?
Sorry?
This one. Where A equals to 5 into C, sir. Where C is some integer in this part.
Listen, surely here 5 only will come, because in this question, we are proving root 5 is irrational, right? So it will only will get 5 only here in this question. No other number.
No other count.
Okay.
Okay, sir.
Listen.
Yes, sir.
Now listen. Since b square is expressed as 5 times c square, therefore I can write, since b square is expressed as the product of 5 and some other integer, right? So I can express it like, therefore 5 divides b square. Is it correct? 5 divides b square. If a number is expressed as product of two numbers, means then that number is divisible by these two numbers. So that is why I can write this 5 divides b square. Yes or no?
Yes, sir.
Since 5 divides b square, this 5 is a prime number that divides b square. Then we know we have to use the property which says if a prime number divides b square, means then the prime, therefore the prime number also divides b. Yes or no?
Yes, sir.
Okay, we got 5 divides b. So please put a box. Already we got 5 divides a. Already we got what we got? 5 divides a. All right, let's see here. Okay, let's show you. Okay, see here, we have already got 5 divides a. Now we got 5 divides b. Okay, please write up to this. 5 divides b.
Done, sir.
Done. Now listen, listen carefully, ma. So the meaning of 5 divides a is 5 is a factor of a. The meaning of 5 divides a is the 5 is a factor of a. As well as 5 divides b means b is, for b also 5 is one of the factor. Is that correct, ma? Since 5 divides a,
Yes.
5 is a factor of a, and 5 divides b means 5 is a factor of b. Therefore we got 5 is a factor of both a and b, according to these two conditions, both a and b. Because 5 divides a as well as 5 divides b, therefore 5 is a factor of both a and b. But initially what we assumed is a and b are co-prime integers. Yes or no? We assumed what we have assumed?
A and B are
A and B are co-prime. But if it is co-prime, means it should not have any common factor except one. But here we are getting 5 is the common factor of both a and b. Therefore, listen, what you have tried is, this contradicts the fact that the fact that a and b are co-prime. A and B are co-prime, because we assume that A and B are, we have taken this A and B as co-prime, but here we are getting A and B have common factor, that is 5. So that is why we are writing this contradicts the fact that A and B are co-prime, because co-prime means that should not have any common factor except one. Okay, this contradicts the fact that A and B are co-prime. Listen, now what we have to finally conclude is, this contradiction arose because of our incorrect assumption. That is why we are getting a contradiction in this step. That is what we are going to conclude. After this, what you have tried, this contradiction, please mute, ma. This contradiction arose because of our incorrect assumption. Please write this step. Because of our incorrect assumption. So which means what we assumed is wrong. That is why we are getting a contradiction at this step, at the final step, because of our incorrect assumption. So what we have to do is, this contradiction arose because of our incorrect assumption, that because we have to write that incorrect assumption also, that root 5 is irrational. Okay, that is our incorrect assumption, that root 5 is irrational. Because of that incorrect assumption only, we have arrived at a contradiction. Therefore, now what we have to do is, we conclude root 5 is rational, because we are admitting that we have made a mistake in our assumption. So we conclude that root 5 is rational. Root 5 is rational. Okay, now hence proved.
Sir,
Yes, ma.
Irrational, sir. Irrational.
Ah,
sir.
sorry. Okay, hence we conclude that root 5 is irrational. Thank you. Okay, hence proof. Right up to this. Okay, initially we assumed that root 5 is rational, and finally we got a contradiction. That is why we are concluding that root 5 is irrational. Hence proof. That's it. Finished, Amma? Is it easy now?
Yes, sir. That's easy.
Please listen. So today, kindly practice these two sums. Actually, now we have seen proving root 5 is irrational. Similarly, we have to prove root 3 is irrational. Both the sums, do it as homework. Please practice. Okay, without seeing, you have to practice these two sums. It will be helpful for your exam. Proving root 5 is
Yes,
irrational
sir.
and proving root 3 is irrational. Okay, so we'll see. Okay, day after tomorrow.
Yes, sir.
Thank you.
Thank you, sir.
Thank you, ma. Bye bye.
And
Thank you. Good night.
Thank you, sir.
birthday, sir.
Bye, ma. Thank you.
Thank you.